Yeah. So I guess this is our first podcast. So it might be a little bit rough, but live and learn.
Exactly. Exactly. I mean, we've had some good conversations, so hopefully people will like what we have to talk about or find it interesting at least.
Yeah. So a little bit about, I guess, me, Christian Aguilera-Sandoval with Supernova Flow Cytometry, where we focus on education, accredited education for flow cytometry, as well as consulting for both cell and gene therapy and flow cytometry for primarily for biopharma and biotechs.
Awesome. And I'll go. I'm Eric Haas. I'm with Ionic Cytometry Solutions, aka Ionic, and we provide data analysis and experimental consulting for all things cytometry, really. But our main focus is high parameter cytometry. So Christian and I, like you said, we're trying our first podcast. Just we've had some really interesting conversations. Like we sat at dinner after Cyto this past June and just said we're gonna have a quick dinner, and then it turned to be 10:30 is time to go to bed. So we figured we can talk for a while, so let's just record it and see what happens.
Exactly. And well, we were just I was Eric and I were just having this conversation of like, what am I doing now? And I was talking about making some AI videos for educational videos for Flow. And the idea, I got it from like just browsing through Insta and watching now videos that are talking about anatomy. Well, those are the ones that I'm really gotten into, where it's just talking very brief, like 150 seconds or maybe 1 or 2 minutes and talking about any specific organ. And I was like, this is really cool for visual learners and very easy way to digest a maybe complex concept and to a bite-sized video. And I was like, why don't I do this for Flow instead of the old traditional PowerPoint slide, which is what I have in the LMS at the moment. But I figure I could always supplement it with this bite-sized videos in case someone doesn't want to sit through slides and would rather just listen to some audio and some cool visuals that are getting the point across.
Right.
And the two that I've been working on right now are for the lecture of the anatomy of a cytometer. And I put together, again, it's the is broken down into the three major facets of a cytometer: fluidics, optics, and analysis. And I made a short, under 2 minute video for the optics and one for the fluidics. And I think it was working out well. Like I said, there's still some kinks I need to work out, but that's just because I'm learning. And for those of you that are interested in making videos of your own or are wondering what I'm doing to put this together, I'm using Nano Banana 2.0 and CDance 2.0 because I did find that CDance
What is
1.5 was a
C-dance?
little
What does
clunky.
that do?
So
C-dance.
CDance, it's more from what I found for the cleaning up the video that Nano Banana does and making it for education slash biology concepts. Because I saw that Nano Banana didn't handle that very well, but the visuals are very nice. So, but I'm using the juncture of both of them to be able to mesh the scientific wording and the voiceover and the biology graphics with Cdance, and then incorporating that with Nano Banana to get that nice put together educational video that I'm doing right now. And it's not so bad. I mean, it does require some investment and some play around because they charge you per the credits. Yeah, and so
Tokens
like
are expensive.
yeah, it gets expensive, especially when you're just testing it out. Like for the first video, it was 90 seconds. I will say I did spend maybe like 40, $60 worth in credits, but a lot of it was me goofing around into like, oh, I don't like that scene. I don't like that scene. I think once I get it down, I'll probably be more like 25 to $40 per small video, but I think it's a good investment to conveying concepts in bite-sized visuals that you could incorporate in social media like LinkedIn or Insta, TikTok, etc. Because I'm now thinking of incorporating a YouTube vid channel.
I was gonna ask if you were gonna put it on YouTube because YouTube Shorts are big. I actually saw something similar of like people using AI to create these videos to post on YouTube basically and get them monetized with like various kinds of easy illustrations or whatnot. But I don't know. It seems some of it seems a little bit suspect. Like I highly doubt that there's millions of people that are going to be able to make money by posting AI generated videos. But if it's a specific niche or like educational thing, then maybe that's more reasonable. Maybe it'll pop up.
Yes, I I agree with you. And right now, what I'm thinking is, how am I going to also protect IP, right? And also that it'd be a little unfair for those that are paying for the LMS subscription that someone could go and view all the videos for free on YouTube. So I'm thinking of
Right.
making it like a hybrid to start with, where some videos will be free and some videos will be behind a paywall, that this paywall gives you access to the LMS as well, and vice versa. If you already have the LMS, using those credentials for the YouTube channel, but I'm still doing some cost benefit analysis to see whether or not that's feasible or how I'm going to work it out. But the idea is bringing them into YouTube. I just don't know under what model yet. But
Fair enough.
and like, and what's the rate of making these videos, right? Am I going to be making like once a week, twice a month, or because it does take
Yeah, what's your goal? I was gonna ask, like, what's your goal? How long does it take to make one of these things?
it took a while. It did take a while. I would say a good hour to 2 hours between the generation and the editing, because and that doesn't count the time that it's taking the algorithm to generate the visuals. So I noticed that some visuals take longer than others, but I don't know. The what took me long time was the drafting of the prompts. And I think that's the challenge, because I
Mm.
noticed that if I wasn't clear what I wanted the visuals to show, it really went a little haywire.
I wonder if
uh,
you could like do some AI inception kind of work and use Claude or ChatGPT to like give you better prompts or help refine your prompts. Say, I want this. Give me a prompt for Nana Banana so I can make a video the first shot and save some money that way.
don't get me wrong. I am using a LLM models to do that. So I
Mm.
first write out what I want that scene to show on Word, right? And make sure that all my facts are correct, because I don't trust the AI models to just generate the prompt with the information, because I'm like, it's probably gonna lie. So I write the content myself first, and then I plug it into Claude or ChatGPT, because I'm actually using both to cross check each other to, and it's kind of like what you said, and I say the goal is to generate an educational video, and this will be one of the scenes for that educational video. I want this scene to be X seconds long, and the goal and the audience is X, Y, and Z. Can you edit what I have already written to be able to give Nano Banana and C Dance the best information possible to generate this scene? And then I generate those prompts using Claude and ChatGPT. And then what I do, I plug those prompts into the AI video generator, and I see which prompt generates the best scene. And after I generate all the scenes, I put them together. I have noticed that there really isn't a better prompt generator.
I was just gonna
Sometimes I
ask
get
that.
better ones from Claude, sometimes from ChatGPT. So I don't yet have a favorite. Again, only made 2 videos. So take that with a grain of salt. This is an N of 2.
Fair enough. Fair enough. Yeah, I've been getting into AI a lot more too. Not as much video generation. That's something that all my interest, but I'm using it a lot to do kind of custom scripting and custom figure generation. It's
Hmm.
gotten really good, honestly. Like using Claude Code can generate your 1,000+ line code script in a few minutes, and then you can go through and just check it and see, okay, what are you doing here? Are you actually doing this? All right, this makes sense. And then it's really nice.
I mean, that makes sense. I've been wanting to get a little bit more into that, but so many hours in the day. So I have to break my day into what I need to do for the consulting, what I need to do to reach out for networking, for my conference commitments, et cetera, and generating content, right? So I'm like, when do we find the time to do everything? But
I know it. I understand that. Yeah, it's hard to find time to do side quests and side projects.
yes. And especially when so one thing that I've been falling down a rabbit hole, and I don't know how many hours I've invested on this. I went to tell you the little story and tell me what your thoughts are. And it is all flow cytometry related. That I went to go visit some clients. I reviewed their data and I listened to their concerns. They're working with the Agilent Option 5 laser, and they're looking at tissues, and we saw their data, and I had some concerns, but what we found out that it has to do with the autofluorescence, right? And as you and I both know, autofluorescence is a big deal if you're working with spectral cytometry. If you're working with conventional, Not so much. Still relevant, and there's still ways to get removal of the autofluorescence. But I found that, I mean, through various papers now that I've been reading, like I said, I've fallen down a rabbit hole, that it's super crucial in autofluorescence for the tissues. And
Yeah, I've
before,
seen and heard that. Yeah, it can be a real problem. A lot of the different like stromal cells and different sorts of larger cells that can contaminate a tissue isolation is can cause all kinds of havoc.
right, and it totally destroys how you want to approach the data. And if it, I don't know, it changed my way of approaching it because I saw that where I thought, well, the outfluence might affect it a little bit. No, it really changes the data substantially to the point that I don't know, and this is something that I think more literature needs to be out there to make one opinion or another, that it could really change the results. Agilent had posted did a poster in 2024 about the different tissues and the heterogeneity of cells and how those influence autofluorescence, and how if you just do a general correction of a tissue, let's say the spleen, I think they use the spleen in that poster, that instead of sample specific, it overcorrects or undercorrects autofluorescence for the different cell types, and making, especially if you're working with rare events, completely masking them, and now you lost them altogether. And I'm thinking, as we're looking into cell and gene therapy, excuse me, how this is going to be crucial for CAR Ts, right? Like, because you need
Right.
to be a little bit more quantitative. This is going completely going to screw that up. So I spoke with Angela, and they don't yet have a video on how you remove the autofluorescence from the different cell types within a specific tissue and assign that autofluorescence signature to identify what cell types you're removing it. Unfortunately, the software doesn't have that
Mm.
capacity. It has limitations. So you're able to identify spectral signatures and try to associate them to cell types, but it's not like you could say specifically this belongs to that cell. It's
Um,
inferred, but
have
with the
you
co-
looked at any of the like self-specific unmixing and autofluorescent, auto spectral type situations? Like there's that's one of the new algorithms that's been released like in the last year or so. Auto, I think it's Auto Spectral is the name of it. It's from the Oliver Burton and that group. And it's
Mhm.
supposed, I've read a little bit about it, but I haven't quite played with it yet. But it's supposed to be able to take cell by cell data and perform unmixing on each cell and autofluorescence extraction on each cell rather than kind of a mean approach that a lot of unmixing and autofluorescence extractions do. So I wonder if that might help in something like this.
I'm not sure, but the other caveat to all this, just to throw another wrench into this already complex concept, is or workflow, is how we approach spectral unmixing, right? So Flojo does the standard, what do you call it, conventional way of doing it. But you could also do a weighted algorithm on it. I'm spacing out on the name, the specific, I believe it's the square sums, or I could be getting that wrong, but is the standard algorithm that they use. But you could check off the little box that talks about making it weighted. I've contacted Cytec as well as Agilent and BD. And it turns out that they all use different algorithms and
Mm.
Sony for spectral unmixing. So I know you're mentioning this tool, but that's for which manufacturer parameters
It's
does
a
the algorithm match?
yeah, I think it's pretty agnostic. I just sent it, put it in the chat here,
Right.
but
But see,
it's
that's where I don't think it can be agnostic, because if you remove the autofluorescence, you still need to do the remainder of the spectral unmixing and how that data is getting resolved, right? Because
right.
if you're because the same argument could be made for like Flojo or FCS Express or any third party analysis. If you do the spectral unmixing in their software, it's not going to match what you're seeing in your cytometer. So if let's think if you were working in biopharma, biotech, maybe also in academia, that when you're doing the acquisition, you see one thing, and when whoever does the analysis on a third party software, they see something else, that could make or break whether those values pass or do not pass acceptance criteria, right? Which tend to be pretty sensitive. So I'd be very hesitant. And then now you're going to have the conflict of whether or not something passes acceptance criteria based on where was it analyzed? Was it analyzed in the third-party software or at the cytometer because of these spectral unmixing algorithms? So,
That's fair. That's a good point, and that's I think there's two things here. One is like the difference between doing more regulated type assays that are having an acceptance criteria as part of the process versus like discovery type of work, which like going to a third party would make sense. Like for instance, the Cyto kit, the little 3D printed flow cytometer that we saw at Cyto from Samson, they put in autospectral into their software. So like this is their like unmixing tool of choice. But anyway, so you have the discovery side of things, but then you bring up a good point of how do you kind of marry differences in softwares and how they look? Because there is a lot of utility and value, I think, in having a third party software that is platform agnostic that can handle different types of data that coming into it. And you're not just reliant on the manufacturer's black box software to do what you hope it does. And sometimes it doesn't work properly like this. So this is something that's come up before too, of like comparing, let's say, Flojo to Omic. Like I
mhm.
personally am a proponent of Omic. I think it's a very nice software to use for like discovery type stuff, especially. It's very streamlined. Flojo is great for quick and dirty analyses, of course, always, and good for simple flow panels. Like, still use that for that. And also the histograms. Like, some people love the histograms with Flojo over anything else. So there's that. But the questions come up of like, okay, in Flojo, my data looks this way, but when I put it on Omic, it looks this way. Like, which is right? And I've done some comparisons, and it's the same data, right? It's just scaled slightly differently, so it looks a little bit differently. But when you're talking about doing compensation in different methods, obviously that's going to change each time. So I'd be curious, like, what do you see on how to marry different softwares, or even if that's a possibility? Obviously, in a very regulated space, like you're going to use the software that comes with the platform most likely. But do you see ways to bridge that and like take data that's acquired on one platform and take it to a third party software to use that? Or yeah, I don't know. I'll let you wax on that.
I've been thinking about this very question that you just asked, and I haven't come up with an answer, to be honest, because I don't think that any of these algorithms that they're using for spectral unmixing is superior to the other. They're just different ways of
Different.
looking at it, right?
Right.
And I haven't seen a real head-to-head analysis between all the different algorithms and seeing
Mm,
how it makes sense in a biological sense, not just in, bio in mathematically speaking, because sometimes they don't make any difference, right? Like
right.
an example would be if you sometimes people when you're doing panel design, people say, "Oh, don't put things that have a high spillover." Well, that's a very generic statement. It's the correct statement, but it's very generic. Like I would say with the caveat of don't if you need to sacrifice spillover or a little bit, do so with markers that don't co-express. And
Right.
it's
Like
right.
CD4, CD8, classic example.
Right. Well, not if you're looking at a thymus, right? Because then it's a mess.
Not
But
fair enough, but that's a very small subset of people.
right. So I would say more like CD4, CD19. The two are never going to be together in the same plot. So I would say that with these algorithms, we need more transparency from the manufacturers, BD, Cytek, and all of them. Instead of them just telling us the general scheme of what their algorithm is like, no, no, no. Let's get beyond this and have full disclosure because this is affecting potentially patient health
Yeah.
and but it's definitely affecting discovery research where I would argue that millions, if not more, of taxpayer dollars are being invested for research. Therefore, the general consumer should have a say into how is that data being used and interpreted for since the US taxpayer dollars are being used for this research. And that there should be recommendation or guidance from the agencies to standardize this. Right now, I think
Yeah.
we've gotten better, but we're still very wild west in flow cytometry, where there's no real standardization of almost anything, right?
Right.
Uh,
Especially
s-
across different platforms, right? Like you run something on a Cytec and you run something on a Sony, you might have two different outcomes based on the differences in softwares and the instruments themselves, but especially on the back end.
yes, and even and when you talk to a lot of sales reps, I love my sales reps, right? But they tend not to be so scientifically inclined, let's say. So I think you need to speak with an FAS or someone that is very well informed and knowledgeable about the instruments and the data analysis and the workflows. Because when you approach a customer, I think, or an end user or an institution with a cytometer, cytometers, I think, now are kind of made fit for purpose, regardless whether they're spectral or conventional. And now you really need to have a strategy of how you're going to choose a cytometer. It's not just who is cheapest, but what's under, how is it looking at data, how is it processing it, and then how is it analyzing it. So I think it falls into the great, I think there's a much bigger conversation, certainly encompasses autofluorescence that we initially started talking about. And it encompasses compensation, like spectral unmixing, and many other things, right? Something as simple as just naming. Everyone is now naming things on their own flavor. You talked about scaling. Everybody looks like differently. So if you have the Option, it goes super high in terms of their dynamic range, as well as Miltenny, but it differs with if you look at Beckman Coulter or if you look at Becton Dickinson now Waters. Again, none of them are wrong, none of them are right, but they're different. So it makes it very hard to compare data from different instruments, which then makes it very challenging if you're trying to evaluate whether the data you generated matches with the data previously published, or if somebody's trying to compare your data that just published, right?
Right.
And it gets more sensitive if you get into the regulated spaces, because then let's say you're on the cusp of accepting or rejecting based on acceptance criteria. Well, do you accept it if it was analyzed with third-party software like Omics or Flojo or SS Express? Or do you accept it based on the manufacturer's cytometer software, like let's say Beckman Coulter, Site Expert, or Web Becton Dickinson's in its regulated space fact suite? While they're not spectral, either of those, but I could see here already and there's movement to get spectral into that space. But we're already
For
seeing
sure.
spectral in the GMP space. So GMP could already be used for analytical development or assay development departments that also have acceptance criteria, right? It's not just QC.
Right.
So I don't know. I think it has really put me at, like I said, I don't know how many hours I'm spending that I'm looking in more and more, and I just realize everybody has their own opinion, but there's no real answer. And I'm just like, this is really bothering me. Because when you're doing consulting to, people are just even for my own knowledge, I'm just like, how do I go about this? Which algorithm do I choose?
It depends.
It
It
depends. And that is
depends.
such a poor answer when you know what I mean? It's like, it's a non-answer. We're just like waving our hands.
Yeah, it depends on what does it depend on? Who knows? It depends on what it depends on. Yeah,
Yeah,
exactly.
exactly.
I
Uh,
wonder
I
if I wonder if there's some utility in like if you could use, let's say hypothetically there's a third-party software that's not a black box that works much better for autofluorescence extraction and doing cell by cell unmixing. I wonder if you could do a fit for purpose validation to use that instead of whatever black box software comes from an instrument and say, okay, we're going to run our samples on on the instrument, obviously using their acquisition software, but part of the SOP is to then take it and analyze it in XYZ software and count on those results.
Don't get me started on validations and qualifications. Now that I've been going down this rabbit hole, it really puts validation and qualifications on their head. I don't even think I mean, I think it's already even challenging for an RUO qualification for academia publishing, right? So like I said, I was talking with these groups that I was visiting, and if you speak to the manufacturers, they'll tell you, let's say that you're looking at the spleen of a monkey, a macaque, or yeah, let's just do macaque. Let's do mice because they're higher at number that you could get. Macaques, you're limited to like maybe 3 or 5, right? But mice, so you have more access to them. But if you're looking at different tissues, according to best practices, what you would need to do is do controls, autofluorescent removal controls per mouse, per tissue. That you could see how it's not
Yeah, I'm sure Jose
practical.
misses that. Yeah,
You know what I
yeah.
mean? Like,
It gets to be a lot very quickly.
yes, like A lot of people do 5 to 10 mice per condition, if not more. But every tissue had people look, generally speaking, 3 to 6 tissues, right? Bone marrow, spleen, liver, peripheral blood, if we want to call that a tissue per se. That's already
Oh wow.
four. Lymph nodes. Some people are doing brain. There's other organs, right? So now you need to multiply that by the number of mice. So let's say you're doing 6 tissues, 5 mice per condition. You have treated and untreated, keeping it simple. Two
Right.
conditions. So now you have
You're already at
five,
60 samples
and that's
times
just
double it.
autofluorescence controls, Eric. That's just
Right. Right.
autofluorescence controls, right?
The
What
whole day
point?
of running at least anyway. Yeah, now you're talking about just the cost of that. It's crazy.
Right, exactly. And I'm just like, no one's gonna do flow cytometry. We're asking people to do this.
Well, I would be remiss not to say that in CyTOF, you don't have this issue. Obviously, I work with all cytometry. I think it has value, but when you get into this kind of realm, it's like, wait, why would you do flow? Just use CyTOF where you don't. This isn't a problem. You know what I mean? Like, you can't help but think that way. Like, it just you don't encounter the same kind of issues here as you do in flow.
True. I would agree with that statement. However, I think it behooves us to figure out a solution to these problems. So new
No
technologies
doubt.
pose new challenges, and challenges are nothing but an opportunity for a solution, right?
Yeah, I wonder what that could look like of something that basically simulates this issue, but is you don't have to run 60 just for autofluorescence.
Right. Well, but it also like puts us to break the way I was thinking. And you tell me what you think about this. I don't know if you noticed that I've been giving this quite a bit of thought.
For sure.
That I've broken now down into two approaches. Short term for the band-aid, right? Because not everyone's gonna wait for the long term. And
Right.
then I have a medium to long term proposal. For the short term,
Curious.
I would say let's treat this as we do with human heterogeneity and say that this is my proposal and this is what I recommended to my clients. It's not feasible to do all these controls for all these mice, right? So let's generate it as a method comparison and compare the prior results to the current results and do maybe 5 rather than 60 something. And but at that point, do look at what are the priority tissues and generate a library bank, if you will, and then collect that data and see of your heterogeneity samples, what is the autofluorescence, right? And create an Allman plot. And now you know what is within 95% confidence interval and 95 confidence interval and what's outside of that. Or you can make it to one standard deviation. And moving forward, if your sample falls out of that, then you have some aberrant sample on your hands. But if all other samples fall within that, I would say at that point say I'm going to skip this control because it's already within my library of acceptance, acceptance, right? And we do that all the time already with other things. We don't stop and overwhelm the systems with controls because at some point you need to run your experiment, and controls shouldn't prevent you from running your experiments. And it cannot be so prohibitive that you cannot run them. Because then people will say, well, then what's the point of spectral cytometry if I then just go to my conventional where it's not an issue, where it's less of an issue, or go to CyTOF where it's not even an issue, right?
Right, right.
Uh,
Yeah, so
so
basically making it as another measure, like what I think of as doing some sort of like batch control almost,
almost like that.
kind of theory in a way of
Yeah.
each batch you're gonna run some number of controls. Maybe yeah, at first I thought maybe a mixed control, but then it would be hard to discern what's what in that. So maybe you run one of each tissue per batch and say, okay, this is what we see. And then over time, you end up collecting. And maybe this is something that's built at the beginning of an experiment or at a study where you run basically like a precision testing kind of workflow for your autofluorescence and say, we're going to take 3 different donors, 6 different tissues. We're going to run them all just as autofluorescence controls, get our criteria of acceptance like you're describing and see, okay, this is what we expect over X number of donors across these various tissue types. Now you have like some sort of acceptance criteria that you can run. Maybe you run a set of controls with each batch, but you can also look at that historical data and say, all right, we know generally this is the trend. Do we
Right.
fall inside or outside of that?
Yes, I would just modify that by saying that I would be hesitant to say how many numbers to create this benchmark or range of acceptance, I would say at that point, incorporate a biostatistician to say, if you use this number of controls, it is statistically possible that you are encompassing X, number of variability within the controls. Therefore, it would be acceptable. So
Right.
I think and which I like, because then it's also multidisciplinary. It's no longer in a vacuum. And that's also going to force people to realize how many controls do you need, not only for autofluorescence, but for other things? Because then your biostats person is going to be like, what is this? You're not including or connect, or why were you doing a T test to show about your T cells? That's the wrong test, right? Because I've seen that all the time. I mean, I recently reviewed a paper where their stats were completely off, and I was like, I don't know why you chose student t-test for everything. That's not how things work. You could tell that this was just,
Some people like
someone
to
that
do
wanted
that.
to take cut corners. But so that's what I'm thinking. It might even be beneficial for everyone because now you're using someone that's an expert in biostats to prepare you to choose the best possible number of controls as well as what statistical analyses to do to bring confidence to your results, right? And whoever's reading it could also replicate it. Because I think that's one of the problems that we're having in science, especially in flow, is replication of experiments. And
100%.
and I think that boils to all these topics that we're talking about, that there's no standardization. You could not replicate if you don't have standardization. So I really appreciate what Ryan Brigman is doing with
SoCap.
SoCap. I'm sorry, I forgot the name,
Yeah.
and I'm part of it, and I forgot the name. I apologize. With SoCap, at least bringing standardization to the naming, right? And that's a first step. But I think we need to, as a community, stand up and demand standardization across everything. And you know what? Manufacturers are gonna complain about this because they're like,
It's
cost, blah
not
blah blah.
proprietary. We can't sell our software for as
Right.
expensive.
And it's then my answer to that is like tough luck. You want to make profit, you want to make business in this industry, you
Do
need
better.
do better. Exactly. We need to hold our manufacturers, hold their feet to the fire and be like, you need to be better and do better. Because we
Right.
all know they're making more than enough profit per instrument. It's not a 1x or 2x. They're making significant profit where we're not eating into their overhead, we're eating into their profit, which I personally think it's okay if it's going to make better data. You know what I mean?
Right. Plus, honestly, I feel like most scientists like openness and transparency. Obviously, there's a whole can of wormhole we could go down if you want to talk about like the academic siloing of data and research and all that jazz and lack of collaboration, which is a problem in of itself. But I think most people do like having transparency. They like to be able to say, like you have a platform and you tell us exactly what it's doing to our data. You tell us exactly what compounds are in your different buffers or whatever it is. So then you can know exactly what it's going to be. Like all this proprietary stuff, like most people aren't going to make their own things unless they're really cash strapped when they could buy something off the shelf that's going to work. They just want to know what's in it.
Exactly.
And I think that's a huge thing. Like if there was a company that came along and said, all right, this is our instrument. This is what we do. We're confident in the performance of our product that we're not going to worry about black labeling everything and making everything into a box. Here's what it does. Here's how you can tune it, play with it, change the settings for your needs for this software. Like this is what it does. And this is what's going on under the hood, right? Like instead of just saying it's our magic, it's our secret sauce, like the secret sauce should be the performance in this field,
Yes.
right? Like if
If
someone came along and did that, they'd take off and take over the market.
Exactly. Like, if your instrument works or if your antibody works, show me the data.
Right.
Don't give me all this marketing nonsense. Show me data, right? And that's where I think we need to go back to the fundamentals, go back to the basics and
100%.
not allow these manufacturers to just swivel their fingers in our mouth and tell us, hey, be quiet. It's our IP. It's a black box. You don't need to know. Just trust us. I'm fed up with it,
Yeah.
and
100%. I
it's an
mean, that's how I do
algorithm at
things.
the end of the
That's how I
day.
do things at Ionic. I don't care. Like, you can see exactly what I do. If we're working together. If you're a client, like, we're in this together. There's no hiding anything or saying, oh, it's just my magic. No, no, no. Like, here's the workflow. Here's what we did. Here's the plots. Like, it's not just take the data, make a plot. anybody could go online today and like say, "Hey, I want you to make me a box plot showing three conditions and show that two are statistically significant versus the other." And you could get that output even without any data. So it's like, I don't understand the non-transparency and the not just, hey, this is how it works. The results should speak for themselves, not here's some slick marketing. It's like, honestly, it reminds me of what came to mind is the Thermo Fisher stuff recently that's been out. If you've seen that, of like how had manipulated Western blot pictures on their website for tons of antibodies and different reagents and all kinds of like fake data. Like I love these people that are digging in and diving deep into this rabbit hole of manipulation of data. It's like if it works, you don't need that.
Exactly. If and we're not in mysticism, right? Of did this spirit or that spirit come down and talk to us and give us the answers to this scientific problem? No, we're working in science based on data. If your stuff works, you know what? There's already legal protections in globally, specifically in the US more so, that get a patent and that's it.
Exactly.
You're protected
Exactly.
instead of
Exactly.
keeping us in the dark that we don't know what is happening because then you're asking us to solve biological problems that are directly related to disease and human health with not with unknown variables and all because of profit. I'm not okay
Yeah,
with that.
I agree 100%. It's so wrong. Like this isn't just a tech field. This isn't anything that like you're making a new app for somebody's phone that they can waste time on. No, we're talking about like making better treatments for people, helping people. I think there's a big disconnect I see a lot, and I think it's pretty prevalent of the direct relationship between like the science and what's being done, whether it's technology or honestly just sometimes people just working in a lab on the same mouse over and over again. It's like, wait, what's the actual end result? What's the end product of this whole system? It's to help people. Like that can't be forgotten.
That's true. And I will say, though, I think we're a little bit bashing the manufacturers. So I do want to say, something positive in that when I reached out to them, they were very helpful and collaborative. They still didn't tell me everything, right? They sometimes said they're like, that's IP. We can't tell you that. But for the most part, they were very collaborative, enough to get me to some answers, although, like most scientists, right? More answers lead to far more questions. But I will say, when reached out to Agilent, they were very helpful. When I reached out to Beckman Coulter, they were helpful. When I reached out to Cytec, they were also helpful and pointed me to a video, which I will say Cytec is the only one that I've seen right now that has an actual helpful video on how to remove autofluorescence at a heterogeneous level, not just like remove it from the blood. It's like that's not going to do anything. And there's other ones. I haven't talked to Miltenny, so I don't want to bash Miltenny and say they were helpful or not because I haven't talked to them yet. But the other ones were. That, however, does not remove, I think, the responsibility they have to the scientific flow cytometry community of just be transparent. Let us know what you're using in your algorithms, or do we need the involvement of the societies like ISAC and ICCS to add pressure and say, no, no, no. We all need to figure out what's the best algorithm that we should be using for spectral unmixing
Right.
or get the
Put it
KOLs
across.
involved
Yeah.
or something and tell the manufacturers, I'm sorry, you need to use this moving forward or you can't play in our sandbox, right? And I think that's when we start moving towards standardization,
Right.
not only putting the onus on the end user, but forcing the manufacturers to also comply. Or maybe we don't need to get to the issue of forcing, but if we bring it up that they volunteer, because we know they've done some effort on this with NIST. Lily presented at Cyto some amazing, phenomenal data for TBNK that some other companies were collaborating with, like iHead, where they collaborated to do the standardization of TBNK. And it sounds silly, right? Because TBNK, I mean, that panel has been around since the 90s. But that also shows you how bad we are in terms of standardization for flow cytometry. That we're barely about to publish on how to standardize TPNK, something that was
That's
from the 90s.
crazy.
We're
Yeah.
30 years behind. So it's like, yes, some of the manufacturers like BD put in their 2 cents on helping, but as well as Beckman Coulter. But you know what? We need to do better. We're 30 years behind. And is it a little too small of their input, I would say so. But I think that also falls on us, the scientists, that we haven't demanded their cooperation or
Right.
collaboration. Because let's be honest, they're not going to do anything unless we prompt them to do so, because it otherwise eats into their profits. They're going to tell us where the demand is, and if we just keep yelling as a community, more colors, that's what they're going to do, right? They're going to
That's
give us
true.
more
And I mean,
colors.
I'd argue that the average cytometry user, that's kind of their main desire, truly, is more colors. And does it give me data? Can I use the data? Okay, good. Can I do something with the data? Not, I'd argue that it's more the people at the in the front leading and saying we need to standardize things, we need to make sure these things are done right. But I don't think the average person doing flow cytometry really thinks all that much about, is this data set that I'm running now in 2026, am I going to be able to compare it to my data set I run in 2027? There are people, I'm not saying no one, but like most people don't think like that, at least
Most
from
people
my experience.
no, and not even, and that's the problem in biotech and biopharma, right?
Yeah,
And it's just mind-boggling that we're still having this conversation in 2026.
right,
I didn't re I mean, I've always known that there's a problem with standardization, but I didn't realize how bad it was until I started like really digging in the autofluorescence issue. I'm telling you, I went down a rabbit hole. It started with heterogeneity of autofluorescence, and I'm just like, we're in trouble
right.
because
Because
it
that just
just, pardon the
spilled
pun,
over.
it's spilled over into all other topics of flow. But I'm just like,
Right,
this
because
is
there's so many
ridiculous.
things. There's so many avenues that need standardized that are done in different ways. Like there's the autofluorescence and the unmixing aspect. There's the staining aspect, the sample processing, the instrument itself and the configuration, the lasers and the different detectors. There's the data analysis, obviously downstream from the unmixing, where people do things in different ways and different methods are used. And then obviously the interpretation, like how do you really standardize that? You and I might gate something, or even using clustering, which we don't gate. Either way, we might say this means it's this versus that, and we might disagree on that. And like, there's good, healthy bits of disagreement, but even for standard stuff, I feel like there's so many aspects that could be standardized that would make things better, or even just like best practices, which of course there's been publications on that, but how many people actually apply them? How many
Yeah.
people are running an assay and actually doing a full fit for purpose validation or qualification, if you will? Because a lot of times it's some of the discovery type work isn't exactly validatable, but it can be qualified. Like how many people do that? Not that many. Outside of like a biomarker discovery and a trial kind of thing, you're not doing that,
Most people are not. Are really thinking their panel through something as basic as your panel design.
right?
When I see so many panels, I'm just like, why are you using this panel? This panel was not optimized for your question. This panel was not optimized for the technology you're using. You copy pasted it from an omit, which
Yeah.
omits are
Yeah.
amazing. I love omits. Don't get me
Yes.
wrong. I recommend
Yes.
omits to everyone, but we should be cognizant that that omit was developed on a very particular technology. And now we don't have that. We have a myriad of technologies out there that all fall under the flow cytometry umbrella, right? And I think now this is like the era of consultants for flow cytometry because there's just so many flavors,
There's
if you
so
will.
much. Yeah.
Yeah. And we could reduce that. And this is, for the finance heads out there, we could reduce the cost of flow if we just standardize, because then
Right.
it's easier to approach. And then, like you said earlier, we could really do best practices. Because right now, if you look at most of the guidances from FDA, CLSI, doesn't matter whom, they try to say, for specifically for your experiment, you need to double check with your experiment, fit for purpose, blah, blah, blah. Meaning, they could only give you so much guidance because afterwards it gets murky given the heterogeneity, if you will, of the technologies and approaches and workflows that it's not feasible to tell someone do it in this template because it may not work between person A and person B. Or like you said, compare your data from 2026 to 2027. Then
Right.
if we can't do that, what's the point? Right? We're spinning our wheels. I would be, if you don't mind, when we do our next, because I think we're already hitting the top of the hour. When we do our, because I think presented the problem, and like you said earlier, we went off on it pretty intensively. And we didn't provide any real solutions. If you notice, we were highlighting a problem I think that needs to be highlighted. And I appreciate this conversation and wondering what you think if, and I would love to hear from audience too, if they could reach out to us. If we could invite somebody from to our next podcast, if we continue this topic from either academia or from biopharma, a CRO. I'd be really interested from the CRO perspective, given that they get paid to do assays. So I wonder how do they approach this heterogeneity and lack of standardization when they're thinking of how do I price this project and what challenges does it pose to them when they're getting shown data from someone else. Right. And you get into those challenges if they show you data and then and the customer starts complaining, but your data doesn't match my data. Do you then
Right.
get a pass by saying, oh, I use a different cytometer or a different approach, a different algorithm? Or what do you do? What is
Yeah,
their
what's the equivalency there?
yeah,
Right.
or are they pushing for standardization or are they telling their customers, no, 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 you're going to follow it based on our thing because this is what we're using? Or is it not even on their radar? Or is it such a low priority that they're just like, well, you know what? We know it's a problem, but we're not going to solve it. So it's baked into our pricing strategy.
Right. Fair. No, we should. That's a great idea. We should get, I feel like we could have several different perspectives come and offer up how they see things and what they see,
Yeah.
what
And
they're
then
doing about it.
hopefully if we could get a purist, right? And that's most likely an academic to tell us how their perspective is when you have to add every single control. Because if you're not adding that control, then the data falls apart, even though for practical purposes it doesn't. But we all know those purists
Right.
to get the other, side of the spectrum, if you will, and see if, what other perspectives are out there. And I think to start stirring up these conversations and hopefully somebody will pick it up and also have a roundtable at a conference. And we make enough noise that we catch the attention of decision makers to start
Right.
paving the field for standardization.
Right. 100%. Yeah, I'm glad we did this, you know? I mean, who knows? This is like our conversations. Who knows where it's going to end up? But I think this is a super important topic that we've kind of unearthed and brought up here. So let's keep digging and see, like you said, see if we can get some other people in to weigh in on their perspectives.
Yes. And wonder if we could also ask our viewers if they could let us know what topics they want us to discuss. And if this is not scripted, we're spitballing our thoughts. I mean, we probably have had these ideas or thoughts that have been, percolating in our minds for a while. They're like
Right.
me with autofluorescence. But you and I didn't sit before this call and say, this is how we're going to approach this. And this is what you're going to say. This is what I'm going to say. No, it's having a candid conversation and
All transparency.
all transparent, right? No black boxes with us. And if we could get other people and get their take on it, I mean, we are a community after all, and see if what other topics they want us to talk about, or if they want an honest review. I think that'd be also cool if we could start doing honest reviews of what we think about certain instruments, right? And not saying that we're going to bash on an instrument. I think we could take it from both perspectives, the good and the bad, and do reviews. I wonder how the manufacturers will feel about that.
Our own unboxing video.
Yes, our own unboxing videos.
I love it. I love it.
Maybe we could put this on the YouTube channel that I'm thinking of, and we could post our podcast there at no cost. I don't know what you think.
For sure. Yeah, I like it.
Awesomeness. Then why don't we wrap up? Because I think we should be limiting it to an hour so we don't talk our audience ears off. And because I'm sure you also have things to do and I have things to do.
For sure.
But I'm looking forward to the next one and having some guests start joining us now.
Likewise. I agree completely. Sounds good, Christian. I
Awesome,
appreciate
Eric.
your time. Let's maybe make
Like,
it maybe we'll try and just meet, I don't know, weekly, every other week and just riff and go for it and try and get some people to join us.
yeah, well, let's do every other week so we have time to like really think about the topic at hand of what we want to discuss. I think we kind of already laid out the groundwork for maybe a part two of lack of standardization. I'm gonna ask Ryan see if he will join us at some
I was
point,
thinking that too.
right? Because he has spearheaded SoulCap. I'm sure he has some thoughts behind standardization and see what he thinks about all this. And not only standardization of the nomenclature, but in the other areas that we're talking about. Because I mean, he, as you know, leads, if I'm not mistaken, omics, right? And FCS Express and all of that now. So It'd be really interesting to hear. And I mean, he's also the future president-elect of Isaac.
I
So
think it sounds like a great guest to have.
hopefully
Yeah.
we're not putting him on the spot and for legal reasons he cannot appear because at the end of the day he's still, represent what he says people
Towards
might
it.
take it from Isaac or his company. So I guess we should say that he would be inviting him as a scientist and not a representative of those organizations and any and all
Right.
comments he makes to not represent the views or perspective of those organizations.
Right. Exactly.
That way there's no misunderstandings.
Exactly. That sounds like a great plan.
Awesomeness, Eric.
All
It's
right,
been a
Christian.
pleasure. Thanks so much, man.
Likewise. Talk to you next time.
All right, talk soon. Bye.